My name is Thomas Ingeman Nielsen. I'm from the Technical University of Denmark and associated also with the DTU campus in Sisimiut in Greenland. And I wanted to start by thanking the organizing committee for organizing this event and giving me the chance to come here and learn about the area, hearing all the interesting presentations and also learn about the local challenges and concerns here. I find that very interesting to hear about and to compare to what I know from the situation in Greenland. And that will be my contribution here, is to tell you a little bit about what are the challenges that we're dealing with in Greenland, and especially how we have been working with one particular community in Greenland in trying to increase their capacity to make decisions on town planning and road construction there. I would like to acknowledge my collaborators here, Johanna and Sonia, who have been deeply involved in the work that I will present here. So I will start by giving you a little overview of what Greenland is. So Greenland is, as you know, the large island that we have here. It's a very diverse country, so it ranges from grazing farmland in the south to some of the northernmost communities in the world that have a very traditional Inuit lifestyle. There are about 56,000 inhabitants in Greenland, and as you can see, most of them are concentrated on the west coast here in approximately 70 settlements around the coast here. There's no regional road network in Greenland. No towns or villages are connected by roads, and therefore, like you know from Alaska, in Greenland we're also very dependent on air transport and sea traffic. And there are 14 airports distributed along the coast in Greenland. And in opposition to what I learn is the case here, actually most towns and villages in Greenland have proper harbors. Yeah, so that's good. And most of the settlements operate in what we call island operations, so they have their own water supply, electricity supply, and all that that you know from here as well. The permafrost conditions in Greenland are very warm, as you can see here. Permafrost exists from around the Arctic Circle, which is located here just south of Sisimiut. And permafrost in the region here, most densely populated permafrost region in Greenland is around -1 to -3 degrees. And then when you get more to the north, to the northernmost settlements, we have permafrost around -8, so more in the range that you see here. What you also see is that the settlements in Greenland have permafrost that is significantly warmer than similar latitudes in Canada, and that is due to a relatively warm current coming up along the west coast of Greenland here. So permafrost affects about 75% of the ice-free area of Greenland. 31% of the population lives in permafrost regions, and much of the community infrastructure is affected in one way or the other. The main international airport hub is severely affected, and there are at least 2 regional airstrips that are constructed on ice-rich permafrost. They're not currently exhibiting any problems, but that will certainly happen at some point in the future. And recently, we've also started to see examples of severe rock slope failures. One, about 5 years ago, triggered a large tsunami that destroyed a nearby village. And we don't know for sure, but it is likely linked to permafrost thaw. I will focus now on the town of Ilulissat. This is a photo from the airplane here, where you can see the town. It's located in the central part of West Greenland here, and it is yeah, much of the Greenland west coast, the populated part of Greenland west coast, is situated similar like this. You can see it's a very rocky coastal area here, lots of bedrock outcrops, and the town sort of situated in that context. A nice natural rock surrounded harbor here. In the background, you can see the icebergs of the Ilulissat Ice Fjord, which is a UNESCO World Heritage Site. What you see here also is that buildings in the town are located mainly on bedrock outcrop, and you have these open areas, sedimentary areas in between that are not developed. And this is another picture from Ilulissat, where you see exactly that many houses are built, or most houses are built on bedrock, and it's mostly the linear infrastructure, so the road networks that cross the sedimentary deposits. These sedimentary basins are old marine seabeds, so very fine-grained silty clay materials, and very ice-rich materials, up to 50, 60, 70% ice by volume in the top of the permafrost in many of these fine-grained deposits. Roads are often built on these elevated embankments, and as you can see here, they are typically, in the main towns at least, they are paved, asphalt paved here. And not surprisingly, they have quite a lot of issues with especially the road system. So you can see how they get a lot of differential settlements and other distresses of pavement here. And the main adaptation action that they do in connection with that is regular repaving of the roads here. And that's an expensive procedure, yeah, the technical department of Ilulissat has had significant budget overruns in the past years in their road maintenance operations. So we've had a long-term close interaction with the municipal government there, and discussed about permafrost conditions and their actions in that context. And what we realize is that there is in the municipal government there a reasonable understanding of the challenges related to building of permafrost, on permafrost, and operations in the area, but they complain about a significant lack of information available to understand the risks and evaluate cost and benefits of different solutions. And especially geotechnical information is needed. There is a lack of geotechnical equipment, trained personnel to operate it in Greenland, so it's very seldom, and mainly in connection with really large construction projects like harbors, that this kind of equipment is brought in from Denmark, and geotechnical service are conducted. So there is no instrumentation for that in Greenland, and there's no legislative or regulatory requirements to do these investigations, and therefore there is no demand. So it sort of bites itself in a sort of, yeah. At least we're not getting anywhere. So yeah, so that's a problem to obtain new information. There is some information available, but it's very difficult to access. And on top of that, there is the challenge of quick turnover in the workforce, which means there is very little institutional memory in the governmental institutions there. So in these discussions with the municipality, we collaboratively decided that it would be a good idea to try to develop some hazard maps for the community, and use that to try to evaluate the risk to the road network, especially focusing on the paved roads. So, strongly inspired by the work of Michel Allard and other colleagues in the Canadian Arctic, we chose to approach this in a traditional risk-oriented way, trying to obtain and collect and compile geospatial information that we could then feed into a sort of hazard evaluation, developing what we call a susceptibility index for the road network there. So the idea was to evaluate the natural hazards in the town area and combine that with some evaluations of consequences and vulnerabilities, and project that onto the road network there. And all the way through, we're working in categorical values of low, medium, and high hazard and vulnerability and so on. So the first step was to try to compile information, and there's very little information available in a spatial sense in Greenland. I saw a map out here on the wall of the soil, a soil type map from the 1950s, I believe. There's no such thing available for Greenland. So we and what we really wanted was an indication of the amount of ground ice in the different areas of the towns, and that is certainly not available. So we tried to come up with some proxies that we could map out across the area. And it turns out that there is actually a lot of old boreholes that were conducted in many of the Greenlandic towns in the 60s and 70s during the rapid development. And there was this project of geotechnical boreholes being conducted across the country. But they're not easily accessible. They are located in a paper archive in the basement in Nuuk, so they're not available really to the local government there. But part of the work here was to digitize these boreholes and they don't have information about ground ice contents, but they do have textual soil descriptions, many of them, and we used that to map out on a hexagonal grid, as you can see here, and divided them into fine-grained and coarse-grained deposits, assuming that the fine-grained deposits in this area are likely to have a high ice content in the permafrost. But there are 3 minutes. Yeah, I will hurry up. So, but there are large areas that are not covered by this information, so we chose to also combine it with information from satellite, from INSAR measurements, where you can look at surface heave, and assuming that areas with large surface heave again corresponds to areas with fine-grained deposits likely to have high ice contents. So I would skip that. So our hazard map is now the colored hexagons that you can see in the background. We mapped those onto the road network, and then we started thinking about how we could include an evaluation of consequence and vulnerability. Consequences in the engineering context is typically taken as cost. We don't have any cost evaluation of the maintenance operations here. So we ended up using repavement frequency of the different road sections which we could reconstruct with the help of the municipality. And for the vulnerability, we looked at the current pavement condition in the different areas, and then we looked at analyzed the network graph of the road network to identify what are the parts of the network that are specifically vulnerable or that would impact the community most in case of failure and disruption. And this is the final road evaluation map that we came up with. You can see the red, yellow, and green colors on the road network. Yeah, and in summary, we already received feedback from the municipality that this hazard map that we produced is very valuable to them, and not only in context of the road assessment here, but also in the context of general town planning. You can see it's relatively small part of the actual road network, around 9% that we evaluated have this susceptibility index of high, but even that small percentage is enough that it's a big expense and problem for the municipality. And all of this was evaluated under current climate conditions. It would of course be very interesting to try to include some kind of prediction of what will happen in the future, but that will require more local site-specific information than what we have available at the moment. And we hope that this will be a good basis also for discussing adaptation of current practices with the municipality. We have consultation meetings scheduled for October, where we will discuss especially snow removal practices and drainage system operation in the area. I forgot to mention that, but that is included also in the hazard evaluation areas of poor drainage, and where they store the snow of the lateral snow removal in the area.